Greetings. Welcome to this event. I'm Jeffrey Bruno. I'm a psychologist and a algae advocate, microalgae advocate, longtime eater of AFA microalgae for over 30 years. And I'm going to share with you some of my own personal experiences as well as research related to health and microalgae. I do want to give a medical disclaimer to start with, that the opinions I express are entirely my own. This video is for educational purposes. This is not for diagnosis or treatment of any medical illness. So to simplify my philosophy on the use of AFA microalgae, I have to say if each of these numbers on the roulette wheel was a health challenge, this would be my response. And so with all type of health challenges, my general go-to is to seek the best medical care I can and to use the AFA algae in an optimal manner to support my recovery. Now, is there any research that suggests AFA algae actually helps general health? Well, there was a huge study that was done back in 1995 on the effects of blue-green algae, the AFA algae, on the nutritional status of first, second, third grade children attending a particular school in Ndaimi, Nicaragua. And there was over 1,500 students enrolled. They found a 80% improvement in grades, and some of this was due to the increase in attendance. Now, one could say, well, this is a malnourished population. It was. And they were only taking 1 gram of microalgae a day, so a small amount, 4 capsules of this AFA microalgae a day. But would this work in American school children? Well, there has been 2 other studies that have looked at the improvements in behavior and cognitive performance with American children. And in the Sierra Vista study that I was involved with, not only was there an improvement in standardized test scores, and these grades are actually based on standardized test scores, that in the American students, there was also reported significant improvement in school attendance, something that works with malnourished children as well as American diet. So to understand the role of nutrition in healthcare is not alternative medicine. It actually is just good healthcare. Now, a lot of people may rely on their multivitamin, and a lot of multivitamins are just synthetic, made from synthetic sources. So some people might be surprised that recently the Trump administration said it plans to give almost $1 billion to Eastman Kodak, which was filing for bankruptcy. It was, a very famous camera and film company, one of the biggest film companies in the world for a while, till digital came along. And why would they give this big money to a Kodak company? Well, they want the company to manufacture ingredients used in pharmaceutical drugs. Over 80% of our pharmaceuticals comes from overseas, and it makes sense to try to have more sources local. But why Kodak? Why a film company? Well, back in the 30s, Kodak teamed up with General Mills, and they became one of the largest producers of vitamin ingredients. And for instance, the film industry uses acetate for producing film at that time, but acetate is also used synthetically to create vitamin E. So most people would be surprised to know that 95% of all vitamin supplements sold are synthetic. And in this, they often come from a coal tar, petroleum, or chemical base. And there's oftentimes additives to synthetic vitamins, like wax that might be used in car or shoe polish is added to as a binder, or titanium dioxide, which is a known carcinogen, might be added as perhaps a preservative, or there's sodium dioxide is actually added to increase the weight of the supplement. So not all nutritional supplements are the same. What I like are using food as my nutrition. But most people think their food sources only come from plants, animals, and sometimes mushrooms, fungi. However, microalgae is a fourth food group that comes from an entirely different kingdom. And I believe that people should actually eat food from all four food groups, from the microalgae, from the fungi, from the plant, and on a limited basis, animal products. So microalgae can represent the other kingdom of food that is little known and little talked about. So that's what we're going to dive into. Microalgae is a different organism from macroalgae. So the seaweeds you get with your sushi, like nori or kelp, that is more of a plant, whereas microalgae, you need a microscope to actually see the structure. It's evolutionarily a lot older, simpler, and has some unique properties that seaweeds don't have. If we look, we can see that microalgae occurred nearly at the dawn of life, right? When about 3.5 billion years ago, there's some fossil evidence that blue-green algae or cyanobacteria occurred. However, we don't see plant life occurring or multicellular life occurring for another 1.5 billion years. Just to give you an idea of both of how early cyanobacteria, blue-green algae appeared on the planet, and then how evolutionarily adaptive it was, setting the stage for other forms of life. In fact, when we talk about when NASA is planning to colonize the moon or take people to the moon, visionary scientists will imagine, well, how could you turn the Mars into a habitable planet? And one area of agreement is microalgae would need to be used to create an atmosphere to generate a greater atmosphere on Mars. There really isn't an atmosphere. There is ice and water supply. And it is thought that perhaps, ancient blue-green algae was mostly responsible for creating our current oxygen atmosphere. And this process could be replicated on another planet like Mars. So microalgae at the bottom of the food chain is really a foundational food that all other life has really come to rely on in one way or the other. But contained within an AFA, here's a diagram of AFA cell, are polysaccharides and glycoproteins, essential fatty acids, a range of vitamins and minerals and enzymes, a high source up to 60% or more of amino acids, in the full range of essential amino acids and practically all of the non-essential amino acids that your body can produce. There's a rich source, a wide source of light-sensitive pigments, antioxidant pigments, and phenols and other compounds that have health benefits. If we look at the differences of Klamath, AFA, microalgae versus spirulina and chlorella, which are the two other main algae, we can note some significant differences. First of all, the AFA microalgae used by New Earth is a wild harvested algae. And in the same way that most people would prefer to have a wild caught salmon, or would want to have, a wild herb because of the vitality inherent in wild organisms, that kind of value is also seen in microalgae. It has greater amount of vitamins. It has a wider spectrum of antioxidants. It has actually the highest quantity and quality of B12 that's been shown to be bioactive, where some of the other algae have not shown to have bioactive B12. It has the widest range of trace minerals. It has, the most omega-3. According to this chart, spirulina and chlorella doesn't have omega-3. I'm not sure about spirulina there. a lot of the research in spirulina, which has done the most microalgae research, shows that the phycocyanins, the blue pigment within the blue-green algae, has all of these health values. And AFA, a cousin of spirulina, has equal amounts per gram of phycocyanin. So we can help translate that research into the benefits we'd expect to see with AFA as well. It does have phenylethylamine, or P is sometimes the acronym, which is described not the bodily function, but actually a chemical that can increase dopamine production in the body, and can actually create more endorphins and enkephalins, and is a powerful immune enhancer as well as a brain supporter. It's actually been shown to mobilize these T lymphocytes, these natural killer cells in the system, in a way that most of the other microalgae haven't been shown to support the mobilization factor. And it's been shown to increase stem cell activity, which I believe the spirulina has been shown to do as well. Now, one of the things that the microalgae can do, because it again is such a ancient organism, and the size of the cell is so much smaller, it actually can support friendly probiotics, so it can help create better microbiome. So in this research, it was shown that the AFA and extracts of ASA not only had antimicrobial properties, but also significantly boosted levels of Lactobacillus acidophilus. So it's good for the gut. We talked about the light pigment molecules as essential dietary nutrients. One example of the interface between light and vitamins is D vitamin. We need, it is helpful to get adequate amounts of light to naturally produce vitamin D in our body. And most adults, the majority of adults and children, are actually deficient in this essential vitamin because of the lack of converting light into vitamin D. There might be other qualities of light pigment molecules that actually help enhance health that we're just beginning to learn about. For instance, chlorophyll, which we know is the molecule that is primarily used to capture sunlight and turn it into food sources, actually has been shown in animal models to be incorporated within the cells, and in this case within the neurons of animals eating high chlorophyll diets. It could be detected that chlorophyll was still operating within the neuron. So in addition to beta carotene, chlorophyll and other light sensitive pigments may be bioactive within the body, and we need to start thinking of these as essential nutrients, these light sensitive pigments. We can see in certain animals that chlorophyll can be operational, not just in plants. So in the sea slug, it's considered a solar powered creature. It actually can take, it consumes algae and actually can take the genes from the algae and include it in its own chloroplast. This is an animal, so it can actually convert sunlight. It's a photosynthetic animal. The spotted salamander also is able to photosynthesize, and during its early development as an embryo, it actually is able to combine algae factors to create the ability to photosynthesize. And even the P. aphid has been able to demonstrate that it can use beta carotene to increase bone growth, vision, and chloroplast production within its own cell. So again, these light sensitive pigments may be doing more even when we consume them as humans than we realize. What are some of these light sensitive pigments? Carotenoids, phycoerythrin, and phycocyanin, There's also a violet pigment that is unique to AFA microalgae that isn't seen in spirulina or in chlorella, that also shows some pretty good neuroprotective and neuroenhancement properties. What's unique about these light pigment complexes in the microalgae is their nano size. So they're actually within the range of a nanomolecule. So your body can readily absorb these light pigment molecules, and they can cross the blood-brain barrier to improve brain function and actually get to every cell with greater ease because just of the size of the molecule. Now, scientists are increasingly looking at cyanobacteria and algae metabolites for use in biology and agriculture. You know, there are a number of current industrial and medical uses of microalgae and algae, but scientists know that this could be greatly expanded. So the phenols are being looked at within microalgae and algae as powerful antioxidants and to increase immune defense and to really support a range of functions as possible pharmaceuticals that can be developed by scientists. The polysaccharides are known to be powerful immune modulators, and the antioxidant properties of light-sensitive molecules are being shown to be increasingly important in their use for health, as well as in sun care products and other applications. So scientists are starting to pay a lot of attention to these particular compounds that are found in microalgae. We know that microalgae is an immune enhancer and a biomodulator, that it can enhance our innate non-specific immunity. It can actually boost adult stem cell production to aid in repair and regeneration. Microalgae can operate as a prebiotic to improve mucosal friendly bacteria and aid intestinal protective function to aid against leaky gut. Phycocyanin, that blue pigment, has been shown, as well as the phenylethylamine, has been shown to be powerful boost for the immune system and to support the right mobilization of our cellular defenses. It's important to know that our immune system is essential for our survival. We wouldn't be alive if we didn't have an immune cell. And without an immune system, our bodies would be open to attack from bacteria, viruses, parasites, and more. It is our immune system that keeps us healthy as we're exposed to a daily dose of pathogens. So one of the properties of the algae that is immune enhancing is actually found in the membrane. It's the polysaccharides that are found in the outer membrane of the AFA microalgae and in cyanobacteria. What's unique is the algae actually has multiple components that are both water soluble and fat soluble, and scientists are increasingly proposing that's the combination of the fat soluble and the water soluble components that really combine to create the powerful antioxidant effects, the immune stimulating and protective effects, as well as the cell signaling defenses that can identify cells that are not healthy. So these microalgae polysaccharides have names. For AFA, immunon, for spirulina, immunolina, and for chlorella, immuurella are the names that have been given to these specific polysaccharides for their immune-enhancing properties. Scientists have proposed that these polysaccharides can bind to common surface receptors and produce similar immune modulating responses in macrophages, killer cells within the immune system that help get rid of bad guys, because they have a common evolutionary structure that is shared between organisms. And so it's really the ancient evolutionary properties of microalgae that are recognized by every organism and have been conserved by organisms because of their powerful immune supportive effects. We see this in numerous research in cyanobacteria, but I'll mention a few. Gita Jensen did some early research on the power of AFA microalgae to boost the circulation of T lymphocytes. And what was unique about her compared to a placebo of where people were given not an AFA algae, but some other placebo, we saw with just in a gram or a gram and a half of microalgae, which is a daily common dose, within 2 hours, there was an increase up to 60%, 40 to 60% increased circulation of T lymphocytes. And these T lymphocytes are largely created in the bone marrow, but they can't do their work until they actually go out into the blood and then go from the blood into the cells themselves and interact with the cells. So the mobilization is a good indicator that they're doing their job. What was interesting, she did 2 studies, the first preliminary pilot study, then a double-blind study, and she found that with people who had eaten AFA over a longer period of time, they had a more robust effect, a stronger effect, that their body was able to benefit more from the ingestion of AFA, which shows that you don't habituate to this. Your body actually gets wise and can even utilize the AFA algae in a better way the longer you use it. But even in naive consumers, people who took it for the first time, there was some effect, but not as pronounced effect as with longer term users. She also noted that the type of immune activation was a mild cell-specific one that wouldn't create extra challenges within the body, and so it was a healthier response that was cell-specific. So it wasn't going to create a storm of inflammatory action. So if you want to really get into the research, I wrote a book, Eat Light and Feel Bright, that has over 800 studies of microalgae, all sorts of microalgae research in there. It is widely researched. There are so many studies on microalgae health benefits, but they're not easy to find. So I spent 5 years putting them together. I hope this presentation supports your understanding of microalgae and your health. Thank you for listening.